For years, Node.js has been a huge part of web development. But if you ever stop to think about what exactly made it so revolutionary when it first showed up, well, in this explainer, we're going to break down the core ideas that really truly changed the game. And look, that's not just hype. The book Node.js Design Patterns kicks off with this incredibly bold statement. It calls Node.js the biggest shift of the decade. So what was all the excitement about? What was so radically different?
Okay, this right here gets to the absolute heart of it. On the left, you've got the old way of doing things. A new user connects and boom, the server spins up a whole new thread just for them. More users means more threads, and that just eats up memory and CPU power. But then you look over at the right. Node.js handles all of its connections with one single elegant thread. It's a completely different way of thinking, and it leads to insane efficiency. But how is that even possible?
Well, it all comes down to its non-blocking secret. This is really the key to understanding how one single thread can somehow outperform an entire army of them.
So first, you have to understand the fundamental problem, the biggest bottleneck in almost any web application, I/O. That stands for input/output. You see, anytime your server has to read a file from a disk or fetch data over a network, it has to wait, and in computer time, that wait is an absolute eternity. In the old model, those threads would just sit there, twiddling their thumbs, completely idle, just waiting for the I/O to finish.
And this is a brilliant way to picture how Node.js solves that problem. Think of that single thread as a hyper-efficient waiter in a busy restaurant. The waiter takes your order, that's a request, and immediately hands it off to the kitchen. But, and this is the key, instead of just standing there waiting for your food, it immediately zips over to the next table to take their order. It is constantly moving, constantly working. It's only when the kitchen buzzes to say a dish is ready that our waiter goes back, picks it up, and serves it. Absolutely no time is wasted just waiting around.
That whole waiter analogy, that's what we in the tech world call non-blocking I/O. The system call, our waiter taking the order, it returns immediately. It doesn't get blocked waiting for the slow part to finish up. And that is how a single thread can juggle thousands of connections at once. It's not doing them all at the exact same microsecond, of course, but it's managing all of them at the same time by just never, ever getting stuck.
Okay, so if the thread isn't waiting, how does it know when the work is actually done? Well, this is where we need a special way to communicate. Welcome to the world of callbacks. But this new way of doing things introduces a really tricky question. What happens if a function is, well, inconsistent? You know, imagine a function that sometimes gets its data from a super fast cache and returns instantly, but other times it has to go slowly fetch it from a database.
If you're not careful with that kind of inconsistency, you risk unleashing a monster.
A really unpredictable and terrifying kind of bug that the Node.js community has a very fitting name for, Zalgo. Right, so what is Zalgo really? It's what happens when a function breaks its promise to be asynchronous. It acts synchronously when the data is right there in a cache, but asynchronously when it's not. And this creates these maddening race conditions. Your code might set up a listener, expecting to hear back later, but because the function finished instantly, before the listener was even ready, it's never called. The result? You get requests that just hang forever and bugs that are so random they feel like ghosts in the machine.
The main tool we have to manage all this is the callback. It's actually a pretty simple idea. A callback is just a function you pass to another function, basically saying, hey, when you're done with your slow work, could you please call this function for me and give it the result? It's like our waiter leaving a phone number with the kitchen so they can call when the food is ready.
So the most important thing, the rule you can't break, is consistency. On the left, you've got the path to Zalgo, this unpredictable, sometimes fast, sometimes slow function. On the right, you have the Node.js solution. Always, always be asynchronous. Even if the data is available instantly from a cache, the trick is to defer that callback just a little bit. That guarantees it always runs in a predictable asynchronous order, and it stops Zalgo from ever showing its face.
So this non-blocking architecture, this callback pattern, these aren't just little technical details. They actually enable an entire philosophy for how to build software.
And it's a really beautiful philosophy. The idea is to keep the core platform as small as possible. Then you build everything else as small, focused modules that do one thing and do that one thing really well. This comes from the old Unix philosophy that small is beautiful. And this focus on simplicity and just getting things done has created this massive ecosystem of reusable packages, which lets developers build amazing applications like they're putting together Lego bricks. So when you combine this super efficient, non-blocking architecture with that philosophy of small, specialized modules, what do you get? You get a platform that is just perfect for the modern web. It absolutely shines at those I/O-heavy tasks, the exact kinds of things that used to bog down traditional servers. We're talking about real-time chat apps, video streaming services, and the thousands of little API microservices that power pretty much our entire digital world.
So at the end of the day, we're left with this really cool thought. The whole Node.js revolution was built on a very simple idea: one efficient thread and a culture of small, focused modules. It kind of makes you wonder, by focusing on doing just one thing well, can all these small, simple pieces really come together to build the biggest and most complex things we can imagine?